burn methane gas from dumps. It could be a trash burner mixed with gas. So other things like that.
I got a question.
Yes.
How come the U.S. transmits it uses 110 voltage instead of 240 in the house? Because I know like overseas they all use 240 and they claim energy efficiency.
The U.S. had gotten started a long time ago at 120 volts, 60 hertz. We use 60 hertz. In many other places, it's 50 hertz, which is the frequency. It was really just a standard that was chosen a long time ago. The 220 is still used. The way it's set up, I don't want to get into too many details here, but the 120 is the standard, and we do develop things that run at 220 and so on in the U.S. As we get more power. But I don't know. It's there's certainly pros and cons to the higher voltage, but that's just, I guess, I have a better answer other than it's a standard that was developed a long time ago. Yes.
Well, this is maybe not the right time to ask this question, but I can't cite you any numbers, but I've seen them that talk about how much power is lost when electricity travels over long distances. And just from that, it seems like there ought to be a lot of money going into research to improve that. Is it happening?
Yes, losses are always a good discussion. We normally figure about 5% losses. Sometimes as high as 10%, depending on what the situation is. But approximately, if you think 5 to 10% of all the 5 to 10% of everything generated here is gone before it gets there. And the losses occur just because electric wires have resistance.
Right.
And it's basically lost through heat. It's lost through the transformation. The transformers have heat in them. You have to have oil inside the transformers to cool it. And that's just part of the transformation process. Now, as far as researching the losses, there are some situations where superconductors are used. But the issue right now with superconductors is we don't have a way to have them act as a superconductor at ambient temperature, or room temperature, or normal outside temperature. It has to be cooled, and therefore it increases your cost if you're going to use a superconductor. So really, it's waiting on technology to improve the conductors to make them more efficient. Yeah, I wish we did have, a lossless wire or a superconductors that we could save 5-10% right off the bat on energy.
If we're looking at building ones, say out to the windy parts of the state of Nebraska, it seems like that would be pretty important.
Well, let me talk. One other thing about losses too that's important is that losses on a transmission system are what we call I squared R, or it's a current squared. Okay, and so what we're doing here, by reducing the current, the amperage, we're reducing losses. By using this large transmission facility, the losses are a lot less to deliver it from the generator to the house. So that's one way that we do reduce losses, is by using a higher voltage line. And then it gets into your cost benefit, that you have to have enough electricity or enough power flowing through it to make it worthwhile to spend all the money to put a large transmission line in. And that's where the planners optimize it on the voltage based on the amount of electricity that's going through it. Okay, that's a really good question. Okay, let me move on into some of the structure of the electric industry itself. The electric industry kind of grew up, so to speak, with vertically integrated, what we call vertically integrated systems. And those are utilities that do all of it. They own the generator, they develop and generate electricity. They own the transmission to take it to the distribution system, and they serve the customer. That's your vertically integrated utility. But now the industry's moved more and more to have separation, to where you have generators that all they do is generate. You have transmission companies, all they do is own the transmission company. And you have load serving entities where all they do is focus on serving the customer. Now, Nebraska's not quite there, just because of the way Nebraska's set up. But you look at states like Texas, for example, has retail choice in most of Texas. So you're sitting there at your house, you can say, well, I don't want to be served by my local utility, I want to buy from somebody else. Like if you're in Lincoln, I don't want to buy from Lincoln Electric anymore, I want to buy from NPPD. They can do that. So that's where they've broken out the utility, or it's not vertically integrated anymore. They're individual providers focused on one aspect. So that's a change that the industry's moving towards. It hasn't come yet in Nebraska. I don't know if it will because of Nebraska's public power setup. If you look at overall in the United States, about half of the fuel source in the United States is coal. We primarily burn coal. Next is nuclear. Well, actually, next is natural gas at 20%. Then nuclear is right there at 19.4%. And then it goes down from there into hydro. And yeah, at this point, wind would still be showing up in other renewables. Wind is still a very small part of the overall fuel source for the U.S. The grid itself is broken up into what we call 3 different interconnections. And all this means is that you take the interconnection, this is called the Eastern Interconnection, and this all operates simultaneously. Everybody's connected very tightly. This Western systems, they operate very tightly, and the same as ERCOT or the Texas. We do have connections between them, but I guess my analogy would be it's like a river flowing in between here, and there is no bridge to allow the cars to go back and forth. You have to take a ferry. So we can transfer power back and forth, but it's not as efficient, and it's very limited on what we can do. You know, we don't have a nice, big bridges so that power can flow freely between those interconnections. Okay, again, the interconnected nature of the grid promotes the efficiency, promotes reliability. If a storm comes through Nebraska and the transmission line gets taken out by a tornado, other transmission lines can pick up the slack, or they can increase the loading on it so that we can continue providing electricity to the customers. They don't even know anything happened. The same with generation. If a generator trips somewhere because of some problem with the generator, all the other generators can pick up that load, and the average customer doesn't even know what happened. You don't even see anything different. You continue on with your normal life. An important aspect, too, is wholesale versus retail. Wholesale power is where power is exchanged to those entities that are going to continue to resell it. Retail is like your average household, or it's sold to the end consumer. Again, I mentioned just a little while ago on some states having retail choice, but most states have it now where anybody can buy it from a wholesale, where you can change your wholesale supplier, where you're not limited to the utility that you're connected to for wholesale. And I just got a couple of quick graphs here that show the usage of electricity. This is an average graph. Don't take this to be the rates that you have in Nebraska, but your electricity usage, your residential is the highest, and that's mainly because of the variability in the usage. You turn it on in the morning, you turn it on in the evening, you don't have a nice steady usage. You compare that with like an industrial or even commercial where they turn it on and we have a nice load for a long period of time. We can provide electricity at a cheaper rate when we're doing that versus the cycling, which costs money to cycle. And if you look at users, most of the customers of electric grid are residential. Some industrial, some commercial. I like this chart. This shows an average price per kilowatt hour, which Nebraska is one of the lowest in the country right now. We're still very, very cheap in electricity. This is an average number, so I want to take this to be what you're paying at your specific meter. It could be a little bit lower or higher depending on who's actually serving you. But Nebraska does have one of the cheapest in the country. Okay, a little bit more on the Federal Energy Regulatory Commission. They are the independent regulatory agency they're actually under the